Good morning, everybody. I'm going to go over the graphs with you real quick. And this is basically how to read graphs, okay? So if you'll look on here, this is on page 334 in your book. Um, these are the distance time graphs. As you can see, time is on the bottom in seconds, distance is on the y, x, y, and distance is in meters. So this is a distance time graph. Distance divided by time, like slope, rise over run, is speed. Okay, it's not that hard. Rise over run, distance divided by time. So that's a speed graph. Okay, when the line looks like this, or the slope looks like this, it's at a constant high speed. It's getting increasing. The speed is getting faster because you can see the meters are going up right here and the time is going. So this is at a constant speed, okay? Now here, you can see on this one, the slope is lower, okay? These are all positive slopes though. Okay, as you see, this one's not going as fast, okay? So if you look at it, you know this one's going faster than this one. I mean, it's already at 500 meters in 20 seconds. This one right here is at what? 250 over 20 seconds. He's going a lot slower. Probably my husband driving. All right, on this one right here, this is varying speed. Okay, so you can see that they're increasing here, and then look what happened here. What happened here? They stopped because the distance isn't increasing. So when it's a straight line like this, they means they stopped. Doesn't mean they're going the same speed. That means they stopped because the distance is not increasing, but the time is. Time does not stand still for you people. Okay, the distance is still going forward, but the distance is not going forward, but the time is still going forward. So this means they stopped, maybe like at a stoplight. Okay, and then and then they got faster. So this would be like a scenario would be like, okay, you're driving down Germantown Parkway, stop sign or stoplight, and then they had to go again. Okay, so these are the distance time graphs which measure speed. Okay, all right, let me go to the next one. Make sure you are reading these stuff in here. Okay, so combining velocities. So you'll see on this boat right here that you have to, this one right here is showing you the current of the river. Okay, so the river is going 5 kilometers per hour, and this boat is going 12 kilometers per hour. So you got to add those, combining velocity. You add those. 5 plus 12 is 17. And if you actually use a ruler and add and like measure this and measure this, it equals this. Okay, so 5 plus 12 is 17. Okay, now on this one, the river is going this way and the boat is going this way. So it's a square, triangle. So you have to use the Pythagorean theorem. Okay, so I think it's the Pythagorean, a squared plus b squared equals c squared, whichever one that one is. Pythagorean? Y'all can't answer me. Um, so if you do that, it equals 13. We're not going to have to do these in class. I just want you to know how to do them, okay? So the way the boat's going, the way the current's going, and then you do that, so it'd be a squared plus b squared equals c squared, okay? I think it's the Pythagorean. I don't know. Now I'm going to have to look it up. All right. And then acceleration graph. Sorry. I miss you guys. Okay, this one right here is a rock falling, and if you look at it, this is a free fall. Okay, so the first second, see, 1 second, the rock is going 9.8 meters per second. Okay, speed, not gravity. Okay, the second one, the second is 9.8 plus 9.8, and that equals 19.6. Okay, so it's 9.8 times 2. It's really hard, isn't it? Okay, now on the third one, it's going to get complicated here. It's falling for 3 seconds. So you're going to have to multiply 3 times 9.8, and that should be 29.4. Hear the sarcasm? Yeah. Okay, so let's see. The carousel, okay? Again, on this one, it's not changing speed once it's going, but it's constantly changing direction. So that's an example of acceleration still happening in the form of direction. Okay, I told you about that yesterday. Let's see, one more thing. Constant acceleration is taking the plane off because it's constantly accelerating at the same rate. And then let me get to the graph. That's what I'm trying to get to, sorry. Okay. So with these aren't distance time graphs, they're speed time graphs. And speed divided by time is acceleration. So these are acceleration, okay? So you have positive acceleration, which means they're speeding up, and you can see this. The speed increases as the time increases, okay? You're, again, learning to read graphs. Speed divided by time, slope, right? Rise over run. And then over here, you've got negative acceleration. So what's happening on a horizontal line in this graph, okay? The speed is staying the same, okay? And then what happens? He slows down until he stops, okay? So this is negative acceleration. So he was going the same speed, 5 meters per second, and then all of a sudden he had to slow down. Maybe there was someone in front of him. Maybe it was a squirrel. I don't know, okay? And then he had to stop. So negative acceleration means stopping or slowing down. And this right here, a horizontal line in a speed time graph means they're going the same speed. A horizontal line in a distance time graph means they stopped. Okay? All right, on this one, so positive, okay, they're increasing their speed. I think that was it for this. Oh, this one. Okay. Linear graph means straight line, okay? If it's a non-linear graph, it means curved, okay? So this is a distance time graph, which means that they are measuring speed, okay? If the line is not straight, a linear graph on a distance time graph, it means that they're actually graphing acceleration, okay? So if it's a distance time graph, which measures speed, and the line is curved, it means they're actually graphing acceleration, okay? All the other ones are going to be linear graphs, but if there's a non-linear graph on a distance time graph, that means that they're actually, instead of graphing speed like they should on a distance time graph, they're actually measuring acceleration, okay? All right, so that's all for the graphs. I'm going to do another video on how to work out acceleration in just a second.